Number 6, which equation has real, rational, and unequal roots? If you recall, roots for a polynomial for an equation are the answers to it. So what it's really asking you is which equation, 1, 2, 3, or 4, will have answers that are real, that are also rational, and unequal means two different answers. So there are a couple ways to do it. The algebraic way would be to remember that the type of answers you're going to get to a quadratic is dependent upon the number under the radical in the quadratic formula, the b squared minus 4ac part, which has a special name called the discriminant. Remember, there are 4 types of numbers that it could end up being. If this value ends up being a perfect square, then you know what type of answers are going to be. Or if it's a 0, you know what type of answers are going to be. So we'll talk about that after we find out each one. Remember that the a, b, and c numbers are the numbers in front of x squared is a, the number in front of x is b, and the number in front or without an x is c. So for problem 1, if I find the value, I get 10 squared minus 4 times 1 times 25. And if you calculate that in your calculator, you'll get a 0. Problem 2, negative 5. Don't forget to put parentheses around it. Minus 4 times 1 times 4, 4c. And if you calculate that in your calculator, you're going to get 9. Number 3, choice 3, you're going to get negative 3 squared minus 4 times 1 times 1. And you're going to get 5 if you calculate that. And choice 4, negative 2 squared minus 4 times 1 times 5. And you're going to get negative 16. So if you recall, if a discriminant value is negative, this means imaginary roots. Now, if you forgot that, remember, this is the stuff under the radical. So really what's happening is you're really doing the plus and minus radical negative 16 number. And that, if you evaluate that, you can actually see an I comes out. Okay, if you recall, a 0 for the discriminant means that you're going to have equal answers, equal roots. Now again, if you forget that, you can put positive and negative radical 0, which is positive and negative 0, and that's the same number, so that's why it's equal. So now you're down to 2 last ones. If you get a 5, that's a not perfect square number. That means you're going to have a radical still left in your answer, and that would give you irrational answers. And again, if you don't recall that, if you put a positive negative radical with the 5 under it, you can't simplify that. Your radical is going to remain, and therefore you have 2 irrational numbers. So when you finally get to choice 2, a perfect square is going to give you nice real answers that are rational, and you're going to have 2 different ones which are unequal. Okay, and if you forgot that, you can put plus and minus radical 9, which gives you 2 nice answers, one with a plus 3 and a minus 3 involved in the calculation. So your answer is choice 2. Okay, now if you don't remember the discriminant method, there is another way to do it, and that's to do it graphically. Recall that the roots of the equation are where the graph hits the x-axis. So I could redo this problem doing it graphically. So I'm going to erase this all, so pause it if you need to write it. So going back to the original problem, okay, so if I put in choices 1, 2, 3, and 4, so here's choice 1. So choice 1, if your graph hits like this, where the turning point is on the x-axis, that is definitely equal roots. So we want unequal, so it's not choice 1. Choice 2, putting that in. Oops. Okay, and then it looks like it's hitting at 1 and 4. If you're not certain, you can go to your table and make sure, in fact, it is hitting 1. 1 is 0, 0, and so is 4. So I can feel good that that is truly a hit, because sometimes it can be deceiving. So choice 2, it's actually hitting at 1 and 4. That means those are the answers. There are 2, so that means unequal answers, and they definitely are real, and they are rational. So I now know which choice 2. But just to see what would happen with choices 3 and 4, okay, so here's choice 3. Now choice 3, I really can't tell where it's hitting. Don't dismiss decimals right off the bat. It's possible that these decimals are in fact good answers. Now we can only have one answer, so we already know for sure it's 2. But if this were the prior answer before you saw the choice 2, you would actually want to know what those answers are. And to get those answers, to know where it's actually hitting, I can look at my table, but I don't see a hit at 0. I can't find my 0. That must mean it's a decimal. So I'm going to check the intersection by doing second trace number 5 for intersection. And on the Inspire, you hit menu, hit analyze graph, and hit intersection. So then I'm going to get my cursor on this calculator close to one of the answers and go enter, enter, enter. Oh, I apologize, wrong one. Number 5. That's better. First curve, enter. Second curve, enter. And guess, enter. And this right here is one of my answers. But it keeps on going. That is irrational. And then finally, when we do choice 4, and I look at that graph, this is clearly a giveaway. The graph is not even touching the x-axis at all. So for a graph like this, when they don't touch at all, that means imaginary answers. So that's what that would look like. Now you are responsible though to know how to visually do the graphs, because they might actually give you the 4 choices with the graphs and you have to be able to read it. So there's the 2 ways that you can answer this problem. Oh, I'm sorry. One last way. The third way is to actually solve out each and every choice. That would take a little bit of a longer time to do it. But if that's the only way to do it, you could physically solve them all out, compare all the answers, and see what type of answers, which choice has answers that are real, rational, and unequal.